Hello everyone and welcome to my channel. So we continue with our revision. In this video we're going to start with question 2 part B, the calculation part. So part B reads, a train starts from a station C. Okay, so it starts from a station C, meaning our initial velocity is 0. Accelerates at the rate of 2 meters per square second. So acceleration is equal to 2 meters per square second and reaches its maximum speed in 10 seconds. Okay, so we have time, 10 seconds. So this is when the train reaches its maximum speed. So time, maximum speed. It maintains this speed for half an hour. So we can say we have time 2 is equal to half an hour, that is 30 minutes. 30 minutes, which is 30 times 60. Okay, let me just write this somewhere else. Okay, so which is 30 times 60. 30 times 60, which is equal to 1800 seconds. Okay, this is 1800 seconds, and then retards uniformly to rest at the station D after further 20 seconds. Okay, so we also have we can call time 3, which is 20 seconds. 20 seconds. Okay, question number 1, calculate the maximum speed of the train. So the statement says the train reached its maximum speed after 10 seconds, and we know that it started from rest. So we can use this equation. V, which is the maximum speed, is equal to U plus AT. Okay, so our V is equal to, our U is 0 plus our acceleration is 2, and then the time is 10. Okay, yes, the time is 10 seconds. Then our velocity will equal to 20 meters per second. This is the first one. Okay, and then the second one says so number 1. The second one says sketch the velocity time graph for the train. Okay, sketch the velocity time graph for the train. Let me just move here. So we know that. So let me draw this graph. Okay, so this is point 0 or station C. There we have the velocity in meters per second, and then here we have the time in seconds. Okay, so the train, if we look at the statement here, the train started from point C, which is point 0 here, started from station C, accelerates at the rate of 2 meters per square second and reaches its maximum speed in 10 seconds. So here, let's have our 10 seconds. So 10, and this is when the train will also reach its maximum speed. So the maximum speed, which we now know to be 20, so 20 meters per second, reaches its maximum speed and accelerates at the rate of 20 meters at the rate of 2 meters per square second and reaches its maximum speed in 10 seconds. Okay, it maintains this speed for half an hour. So half an hour, we said half an hour is 1800. Okay, so meaning it will maintain this same speed up to somewhere there. Now this point, this is where 1810 seconds is, because it is 1800. And then okay, so 1800 or half an hour, and then returns uniformly to rest at station D after further 20 seconds. So here, where the train goes back to rest, we expect to have 1830 seconds, because we're just adding 20. Okay, so this train moves like this, so we can draw something like that. So the train is moving from this point to that point, and then it goes to that point, and then goes back to rest like that. Okay, and we have something like that. Okay, so this is the velocity time graph for our train. Okay, then question 3 says determine the retardation. Determine the retardation. So the retardation is negative acceleration or negative acceleration. So question 3, you can write it here. For retardation, we can use the same equation, which is v is equal to u plus a t, but we just have to make a the subject of the formula. So a will equal v minus u over t. What we did here, we just so here we're just making a the subject of the formula. We know that when u goes this side, it will be negative, so we are going to have v minus u is equal to a t. Okay, and then since we are making a the subject of the formula, we divide both sides by t. So divide t there, then we're going to remain with a is equal to whatever is on this other side. So that is what we have here. Okay, now that you know that, we continue. So we have our v, which is 20, and then u is 0 there. No, sorry, since this is the retardation, we are calculating the retardation because the train is moving now from this point to that point. So this one will be our initial there, and in our initial will be 20 now. So our a will be v, which is 0, because the final will be 0 there. So v will be 0 minus u, which is our initial 20, over t is 20 again. Okay, so we're going to have a equal to negative 20 over 20, which is equal to negative 1 meter per square second. Okay, so since our acceleration is negative, meaning it is retardation. Okay, so we continue. Number 4 says determine the total distance traveled. Determine the total distance between station C and D, total distance between station C and D. So our D is here, C is there, D is there. So here we just find the distances, because if you look at this graph, it has been divided into these shapes. So we have this part, we have that part, and we have the middle part there. So we just determine the distance for each part. So here we'll find, for this triangle here, we are going to use this formula for distance. So distance is equal to ut plus at squared over 2, which is the same one as what we're going to use here. S is equal to ut plus at squared over 2. And then here, since so we are using these equations for that part there where we have the triangle, these two equations, because the acceleration, the train is moving with a constant acceleration. For this part, we'll just use, because the acceleration is 0 but it's moving with a constant velocity, so for this part we'll just use the equation for distance under constant velocity, which is this one here. And then after we find the three distances there, we'll be able to find the total distance by just adding them all. So for the first one, we know that our initial, for this triangle here, we know that our initial velocity is 0, and then the final velocity is 20 there. Okay, or we don't even need the final velocity, we know that the time is just 10. So here we're going to have s is equal to u, which is 0, times time, which is 10, plus a, which is 2, times time, which is 10 squared over 2. Okay, so our distance will equal 2 times 10 squared is 100 over 2. So this 2 and this 2 will go in this distance there. You can call it distance 1 is equal to 100 meters. Okay, so we have 100 meters there. Okay, and then here we have the distance will be 1810 minus 10, which is just the time 1810, which is just 1800. 1810 minus 10, which is 1800. And then the speed is 20, or the velocity is 20. So here we're going to have 20 times 1800, which is equal to, so what is 1800? Just get the calculator. So 20 by 1800, which is equal to 36,000. So distance here will be 36,000 meters. And then the other part here will be, and the other part here, we are going to have the same equation. So here our u will be 20. Okay, let me just move this a bit this side, a bit down. So s is equal to u 20, and then t it's also 20 plus a is equal to -1. Remember we said a is -1, so -1, so we can put it in brackets, times t, which is 20, and then squared over 2. Okay, so our s will equal 400. 20 by 20 is 400, minus 20 squared is 400, so minus 400 over 2. Okay, so our s is equal to 400 minus this one, okay, so that one will be 200. So our s, so we can call this one s2 and then this one s3. S3 is equal to 200 meters. So these are the distances for each portion. So what we are going to do here is just add all these. So we already have 36,000 there, plus, so just say plus 100 plus 300. Okay, so we are going to have 36,400. No, plus 200, so it's 36,000. So the total distance is equal to 36,300 meters. So this is our total distance. What is our total distance? It is 6,300 meters. Okay, what is the other question? So we can look at the other question. Okay, here question C, but C says a body is dropped. Let me just grab this. Okay, so it says a body is dropped from the top of a tower and it reaches the ground in 4 seconds. Calculate the height of the tower. Okay, so here we have a tower like that, and then we have a body, so a tower that has got a height, then we have a body that is dropped, so it is moving in that direction, it is dropped, and then it reaches the body is dropped, okay, so it reaches the ground in time 4 seconds. So they're asking us to find the height of the tower. So what we know is that since this body was just dropped, it is undergoing a free fall where acceleration is equal to negative gravity, which is equal to negative 9.81 meters per square second. So let me just write this one properly. Okay, and we also know that the initial velocity of the body is 0. Okay, so here we've been asked to find the height, so we can use the equation for distance, because the height is the distance. So the equation for distance is equal to ut plus at squared over 2. Now here we know that s is h, so h is equal to ut, so a is negative g, so minus gt squared over 2. Okay, so this is the equation that we are going to use, and our h will be given by h is equal to, we know that u is equal to 0 minus g is 9.8, okay, times t is 4 seconds, so 4 seconds squared, and then over 2, everything there over 2. So our h is equal to, let me check. Okay, so our h will equal negative 9.8 times 4 power 2, which is equal to that, negative that, and then divide 2, okay, which is 78, negative 78. So our h is equal to negative 78.4, is it negative 8.4? Okay, negative 78.4 meters. So it is giving us negative because the body is moving from the top coming down. So since we cannot have a negative height, the height is just equal to 78.4 meters. So this is our height.